Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The interview you're about to hear with physicist Wal Thornhill was recorded on Monday, April 8, 2019, in anticipation of the scheduled release of the so-called first ever direct image of a black hole, which occurred on Wednesday, April 10th. Now, whenever we talk about a space science story which has crossed over and become a major international news headline, we seem to attract an inordinate number of viewers who have little or no prior familiarity with plasma cosmology and the electric universe theory. The problem is that the overwhelming majority of the general public have no idea that any theoretical alternatives to the black hole exist and should actually be taken seriously. So here's a brief segment from a possible elevator speech for newcomers to plasma cosmology and the electric universe. Plasma cosmology is a model of the universe which recognizes the now undeniable significance of plasma and the electromagnetic force in the cosmos. For several decades, plasma cosmologists have successfully reproduced in laboratory experiments many astrophysical phenomena. An electric plasma universe predicts, and in fact requires, the pervasive and shockingly well-ordered cosmic magnetic fields, which are now recognized, but are not explained and were not predicted by gravity-centric cosmology. And for decades, it's been proposed that at the center of galaxies is not a black hole, but rather a physically real object which is produced and observed in laboratories, called a plasmoid. Now, you've probably never heard Neil deGrasse Tyson or Brian Cox talking about plasmoids, but that doesn't make them any less real. So what is a plasmoid? Well, the term plasmoid was coined by the physicist Winston H. Bostick in the 1950s. Bostick described a plasmoid as follows. The plasma is emitted not as an amorphous blob, but in the form of a torus. We shall take the liberty of calling this toroidal structure a plasmoid, a word which means plasma magnetic entity. Now, Bostick is probably most famous for having performed many experiments in the plasma lab which reproduce the formation and evolution of spiral galaxies. Now, Wal Thornhill explains in this interview in some detail the nature and properties of plasmoids. And for viewers who wish to gain an understanding of what plasma cosmology and the electric universe actually propose for the phenomena that astrophysicists attribute to, quote, black holes, in the comments section, we have pinned a comment which will feature a dozen or so relevant links to previous Space News episodes and a number of other resources. So finally, as I begin to play my discussion for Monday with Wal Thornhill, bear in mind again the description of the plasmoid as a, quote, toroidal or donut-shaped structure. Now consider this side-by-side comparison of the plasma cosmology prediction of what's actually at a galaxy's core, which is the aforementioned extremely dense, magnetically confined hotspot called a plasmoid. And to the right, we see the image that has been touted as the first picture of a black hole, of course with no alternative being considered. So here now is part one of my two-part interview with Wal Thornhill, recorded April 8th, 2019.
On April the 6th, the phys.org report says scientists are set to unveil the first picture of a black hole. The thing is that the picture itself is actually a virtual reality image, like most of these deep space images turn out to be. And that's because the imaging algorithms that were developed to fill the gaps of data, and they say the gaps of data we are missing in order to reconstruct a picture of a black hole. So in other words, it's the algorithms that they've developed based on their understanding and their assumptions about what it is they're looking at that will generate this image. Well, just granted that they are looking for something at the center of the galaxy, which would appear about the size of trying to photograph a golf ball on the moon, according to this article. There is plenty of opportunity for making the image look like what you expect to see. Mm-hmm. And this has happened, of course, before. It's just like the gravitational wave detectors that were built to detect gravitational waves. Well, all of the assumptions were built into that so that they had to find something. Mm-hmm. So they had hundreds of thousands of templates against which to match these signals. And then, of course, the signals have to be sort of pulled out of the noise. They're looking at signals that are incredibly tiny, which gives rise, of course, to the possibility that what they're seeing is like making faces out of clouds. The notion that black holes exist is based on gravitational theory. Now, gravitational theory, according to modern scientists, is that of general relativity, Einstein's general relativity. But the problem with that is, and it was best described, I think, in a television program put on by the BBC, which showed Brian Cox explaining the genius of Einstein in looking at a falling cannonball and a feather in a huge vacuum chamber. And of course, the two fall together. And what Brian Cox said was that Einstein's genius was that he said they're not actually falling. In other words, it's all an appearance. But the only way you can get away with that is to disregard everything else that exists in the universe, which was a tendency of the mathematics of general relativity and also special relativity. Special relativity makes all observers, no matter how they're moving, equivalent, which is sheer nonsense. The only way you can do that is to disregard the rest of the universe, because their motion will be different for different observers with respect to this background of all of the stars and matter and the rest of the universe. So it's a weird kind of perception that's induced by Einstein's theory. The electric universe has followed the guide of the plasma cosmologists, the plasma physicists who've done real experiments and developed a simple theory which explains what is at the center of our galaxy and other galaxies, and that is a plasmoid. Now, a plasmoid is a concentration of electromagnetic energy caused by electric currents flowing in along the spiral arms into the center of the galaxy. And this is seen in the laboratory, the plasma laboratory, in terms of what's known as a plasma focus, where you have a central conductor and a surrounding cylinder with a large voltage difference between them. And you produce that voltage difference by having a huge room full of capacitors, stored electric charge, which you release suddenly. What you do then is you create a discharge which runs down the cylinder, between the cylinder and the central electrode. And when it comes to the end, it moves out beyond the end and curls back in on itself and forms this tiny plasmoid. Now, a description of all of this and the physics behind it was given by Eric Lerner in his book, The Big Bang Never Happened, which was published in 1991. It's easily understood, it makes sense, it conforms to electromagnetic theory, and it is all about electrodynamics, that is, the movement of charged particles. And when you think about it, the universe is formed by moving charged particles. So the governing force in the universe is what's known as electrodynamics, not gravity. And in particular, spiral galaxies, their form and the way they move is easily explained in terms of electrodynamics, not gravity. Now, when you concentrate a huge amount of electrical and electromagnetic energy in a tiny plasmoid, the energy storage means that it appears to have a lot more mass than you would expect in such a small space. Also, the plasmoid has a donut shape. So it's quite likely that what we will be told is that they've seen a glowing accretion disk, but gravitational accretion has nothing whatever to do with it. It is all electrodynamic. So yes, there can be, or they should actually see a glowing donut-shaped object, quite bright because there's an awful lot of radiation and so on from this object. And in the center, there will be nothing. No black hole, just the plasmoid. And it's only when the plasmoid begins to break down that where the electric and electromagnetic forces are greatest, that is in the center of the donut, that is where the breakdown occurs and you get these jets formed. Now, jets from a black hole are an incredible nonsense when you think about it, because black holes are supposed to suck everything in, and here they are forcing jets out along the rotation axis. Maybe I should expand a bit on what these jets are and how they're formed. If you can imagine that the plasmoid has a combination of both positive and negative charges in that plasma, and this is quite normal for a plasma, where they become forced closest together is in the center of the donut, if you like. And when the density of these particles reaches a critical point, the protons and electrons may actually join together to form a neutron. And the neutrons then are not subject to the electromagnetic forces that have held them in place. And this is why they escape in the form of neutrons. And the neutrons, of course, decay in a matter of minutes, but that's enough time for them traveling at relativistic velocities to get away to then become positive and negative particles once more. The electrons tend to be trapped longer by the powerful magnetic fields involved. They tend to spiral around much more tightly than the heavier protons. And so you get an electric current flowing along these jets. And this has actually been measured by the magnetic fields they create. And these currents are huge. So the whole galactic environment and behavior and appearance can be explained electromagnetically, and has been done so by plasma cosmologists decades ago. But of course, astrophysicists and the over-specialization of science these days creates walls between people, even within the same discipline. It's difficult often to get ideas broadcast and discussed rationally, and rational decisions made based upon rational argument, even within individual departments, let alone across departments in a university. So in some ways, our institutionalized education and research system fails us dismally. And this is why we get away with this huge expense on things like the gravitational wave detectors, when no one actually knows what the gravitational force is, and event horizon telescopes, when even the very concept of the event horizon for a black hole is nonsense. The answers all lie in getting a grip on the real history of science, because we actually lost the plot at the end of the 19th and beginning of the 20th century. It's as if the human race went rather berserk in both politically and scientifically at the same time. Mm-hmm. And of course, the history that's taught to students is sanitized. You only hear about the people that they want you to hear about, and those who had other ideas are not even compared against the ideas that are so-called, accepted science or consensus science. The whole idea of consensus science is nonsense anyway, because the truth is not found by a vote.
Well, an unspoken agreement that lurks behind this kind of media sensation is the assumption that no basis exists for anyone to doubt the black hole's existence. So here's a very simple question for you. What is your response to the astrophysicist who says that the existence of black holes is an established fact?
The questions to ask an astrophysicist in return for any dogmatic statements is to define mass and energy, because here we hear these black holes have masses of millions or even billions of suns, and they're compressed into a space where the mass resides in a singularity. Well, a singularity involves infinity, and you're no longer talking physics when you introduce infinity, because infinity is merely a concept. It's not a thing, it's not a number. You can't use it in mathematics, as schoolboys were taught when I went to school. But it's a word that's often used in reference to black holes and also the Big Bang. This gets back to Eric Lerner's book, and why it's important to read it from the physics point of view is that he deals with these things. The plasma cosmologists don't deal with infinities. They have no need, because the electric force is so much more powerful than gravity that you can ignore gravity, and they've actually tested that in their supercomputer simulations of their experiments. And they can include gravity quite easily in the simulation, or they can leave it out, and it makes no difference.